Okay, today's lesson, we're going to learn how to compare functions. So put today's date in, 3/31. When we get done today, your note sheet's going to get taped into page 85, and then there's a sheet for you to practice. Once we check it, you'll tape that on page 86. Here we go. All right, first things first. What we need to do to compare functions is to look at their properties, such as slope. Remember, slope has a fancy term called rate of change, but they're really the same thing. To find the rate of change, we can use our slope formula. y2 minus y1, that's your change in y, over x2 minus x1, that's your change in x. We always write this as a fraction because that's how we use slope patterns when we're graphing. We like to see the rise and the run on our graph as the pattern between our points. Remember, you can also compare using the ratio of rise over run. It's the same thing. It's the change in y over the change in x. We just use different terminologies sometimes to make it easier to work on the problems that we have. So, for some examples to practice. When you get an equation, this is written as y equals 2/5 x plus 9. What you need to remember is when you have an equation in y equals form, this is called slope-intercept form. The slope is always located in front of the x variable, and the y-intercept is always located down here at the end as the constant term. So if you're looking to identify the rate of change, you just need to remember rate of change is just your slope. So our slope is right there. It's given to us as 2/5, and we don't have to do any work to find it. For the second question, we do have to do some work. We need to use our formula that we talked about a minute ago. We need to take the change in y. So we're going to take our y2, and we're going to subtract our y1. We're going to divide that by our x2 minus our x1, our change in y over our change in x. You should remember doing this earlier in the year when we first started talking about graphing. To organize ourselves, we have to keep track of which point is which. This is our first point. Points always have an x and y value, so we're going to call this x1, y1. We're going to call this x2, y2, because it's our second point. Now that we have everybody organized, we can plug our values into our formula. So our y2, we labeled that 9 as our y2, our second point's y value. Our first point's y value was 7.5, so we're going to plug that in next so that we can find the change in our y values. On the bottom, we're going to find our change in our x values, so we need x2 minus x1. The last step is super easy. You're going to find the difference between our 9 and our 7.5, and then you're going to find the difference 6 minus 5. So your rate of change, we can just reduce this and call it 1.5. If you don't like using decimals, you can use a fraction 1.5. You could also just use the mixed or the improper fraction 3/2. There's two examples of how you would find rate of change in an equation or between 2 points. Another example is if you have points in a table. This table has your x values or your input values across the top. So in order to find the rate of change, we also want to look at the slope. Remember, slope can be found by looking for the change in y values over the change in x values. This is another version of our slope formula. When you look at the change between x values from here to here and here to here, you're going to see that we increased by 2 going from 5 to 7, and then we increased by 2 going from 7 to 9. So that means our change in x is a positive 2. Change in x, remember, always goes on the bottom of our slope fraction. Now you're going to look at the change in your y values. To get from -5 to -11, we had to drop 6 values. To get from -11 to -17, we also dropped 6 values. So this is going to help us with our rate of change for the y, the change in y. So if we compare our -6 change in y over our 2, which is our change in x, we can divide that out and get a simplified value. The rate of change for this table of values is -3. We also have a graph to look at. When finding the slope for the rate of change, we need to use our formula rise over run. You might remember drawing slope triangles. A slope triangle, remember, needs to connect 2 points on your graph. Now, what's a little frustrating is if you don't have the 2 points plotted clearly for you. You have to sometimes look to see where the line is going to cross one of the grid lines perfectly. And it looks to me like it crosses perfectly here, and then it crosses another grid line perfectly here. So I'm going to use these 2 points here that we found ourselves to draw our slope triangle. Slope triangles, remember, are right triangles. They go up and they go over to connect your 2 dots. And sometimes we like to shade it in so we can see easily what we've done. We've gone in the y direction. Our rise value is only 1 box. It's 1 unit. So we do have to be careful to make sure we're really using the units on each axis. So the y-axis goes up by 1 unit each, so we know our rise is 1. The x-axis also goes in units of 1, so we can count our boxes. We go from this corner over 1, 2, 3, 4. So our change in y, or our run, is 4, giving us a rate of change or slope that's 1/4. Remember, it's also positive because it's going uphill. Remember, slope dude says puff, puff, positive. Now you're going to look at another situation. You are to use your knowledge of rate of change to help you compare the following functions. So at first glance, you might think that there's only one function described to us in this table. There's actually another piece of information. So I find it helpful to read carefully and then label the information that I have. If Ty sells signs in a monthly craft fair and he can make 7 signs every 2 hours, that's one piece of information that we need to look at. This person's name is Ty, and he can make 7 signs every 2 hours. The other information, which I find helpful to use a different colored pen, is about another person called Harrison. Harrison helps him make signs, and the rate at which Harrison makes signs is in the table. So we need to remember that this is Harrison's information down here at the table. We do not have a table to describe the rate that they gave us about Ty making his signs. So the job we have ahead of us is to decide who's making signs at a greater rate and then tell how we know this. The best way to work on a problem like this is to get the values organized according to maybe x and y, since that's what we typically use when we talk about rate of change or slope. So if these are your x values, you can see, at least for Harrison, that there is a consistent change in x. So for our value for Harrison, we'll make a little note that our change in x, which goes on the bottom of our fraction, looks to be a positive 4. You're going to want to now look at the change in the y values. The change in y values will go on the top of our slope fraction. To go from point to point on our y values, you can see that there's an increase of 15. So that means we have a change, or a rate of change, of 15/4. If we go back to look at the information we have about Ty, he can make 7 signs every 2 hours. So if you look at the way we labeled our variables earlier, these were our x values, the signs, the hours were our x value. So if our x value is 2 for Ty, we can put 2 in the x value spot for our formula. Remember, slope is change in y over change in x. So if we look at the variable x, in other words, hours for Ty, we would put 2 on the bottom, and then 7 signs. Signs is correlating to our y variable. So since we know he makes 7 signs for every 2 hours, what we can do is we can change those fractions into decimals. Decimals are much easier to compare. So as long as we have the equivalent decimal to our fraction, we're going to be able to see that Ty, if we want to look at it, makes 3.1 signs for every 1 hour. And if we go back to Harrison's information, we have to take 15 and divide by 4. When you take 15 and divide by 4, you get 3.75. This means Harrison can make 3.75 signs every hour versus what Ty can make, 3.5 signs every hour. So your answer should be something like this. Harrison makes 3.75 signs per hour compared to Ty's 3.5 per hour. And I think with the work that we've shown, it is pretty clear how we know. We've shown our change in y over change in x. We've shown that we've divided it out, and we've shown that we're able to compare our fractions and make sense out of the problem. Now we have to answer the question about after 12 hours, what would be the difference in the number of signs that each friend has made? Well, the good news is Harrison's information does go out to 12 hours. So we know exactly how many signs he makes after 12 hours. What we don't know is how many signs Ty can make after 12 hours. But we do know how many he can make in 1 hour. So let's use that and set up a little proportion. Ty can make 3.5 signs in 1 hour. If we want to figure out how many he makes in 12 hours, we know that we would have to take our fraction and we would have to multiply by 12, not only on the bottom, but also on the top. So 3.5 multiplied by 12, I believe, is 42. So that means that Ty can make 42 signs in his 12 hours. And Harrison makes 45 signs in his 12 hours. So if we take and find the difference between the number of signs that each friend's made, I believe we're going to end up with 3 signs. Now we're going to look at an example that's very similar to the last one. This one is talking about Julie's family filling up a pool in her backyard. We're going to compare this equation that we have been given, which is to be used to show the rate at which the pool is filling up with water. Y is the total amount of water in gallons. X is the amount of time in minutes. So remember, this information is about Julie's family. That is one function that we're going to look at, but we're going to compare it to her neighbor, Elena. Elena is also filling up her pool as shown in this table below. Instead of labeling these values with X and Y, they've labeled it with minutes and gallons. So if you go back and read that second sentence again, Y is the total amount of water in gallons. So let's label our gallons the Y variable so we're consistent. X is the amount of time in minutes. So again, we'll be consistent by labeling our X values and labeling our Y values. We want to know whose pool is filling up at a faster rate, and how do you know? Well, let's go back to Julie's information. Julie has been given, or we've been given this equation to look at for Julie's pool. The rate, remember, or rate of change, is really just your slope. So if you look at your equation, it's in y equals form. Our constant term is 8,400. So this is not our slope. Our slope is down here. Remember, it's always the coefficient to x. So for Julie's family, we have 5.2 gallons per minute going into the pool. So we'll just write that down. For Elena, we want to look at our change in y over change in x to get the values for her slope.